بسم الله الرحمن الرحيم والصلاة والسلام على رسول الله. حياكم الله جميعا. Today I'm going to talk about the Phacodynamics, the basic part. Tomorrow the clinical part will be covered by Dr.Turki Bin Dakhil. Before talking about the Phacodynamics, let us take a few points about the hardware. The slide is moving or not? Just a few points about the hardware of the Phaco machines. This is the first Phaco machine developed in 1965 by Kellman and his group. And they did the first human Phaco surgery in 1967. They spent around 3 hours in that surgery, and unfortunately they end up with aphakia. Since that time, there's a huge evolving happened in terms of hardware and Phacodynamics. Almost all the Phaco machines should have the same parts and same principles with different features and different designs. This is the Phaco machine parts. It's containing the console, which is the main part of the Phaco machine, containing the pump and containing the energy source, as well as the screen or control panel. The other part of the Phaco machine is the foot pedal and Phaco handpiece with the connections and tubing system. We'll try to have a view information about each part in coming few slides. Starting with the Phaco handpieces. By the way, we have a special handpiece for each main function, like Phaco handpiece, aspiration, irrigation handpiece, as well as the vitrectomy and diathermy handpieces. In talking about the Phaco handpiece, almost all manufacturers had the same structures and the same parts with different designs. So we have here the Phaco tip or needle, we have sleeve, and body of Phaco tip, body of Phaco handpiece, as well as the tubing system. Phaco tip is made by titanium, and there is 4 features and variables that differ from machine to another. First feature is the size. We have the standard size, which is around 1.1 millimeter of outer diameter. Nowadays, there is another size, which is smaller gauge, around 0.9 millimeter in outer diameter. The second feature is the general design of the Phaco tip. Most commonly, we have the straight Phaco tip or curved Phaco tip. Curved, they call it Kellman Phaco tip. The other feature of Phaco tip is the end configuration. What do we mean by end configuration? As you can see here, and let me choose the laser pointer. As you can see here, this is the end configuration, which is the configuration of the Phaco needle opening. We have 3 almost or 4 configuration. We have round, flared, or mini flared. Flared means that the slight expansion of the tip ending. The last feature is the angle. As you can see here, the angle means the bevel angulation, and we have different angle degree, starting from 0 until 60 degree. The most popular one is the 30 and 45. In order to increase the cutting efficiency, you have to choose the larger angulation, like 45 or 60. You can use it in hard cataract. And for better flowability, better holdability, you have to choose a smaller angulation, like 15 or 30. So all these features of Phaco tip, you cannot manipulate any of these features. Only you can choose the angle of the bevel. So you can choose 30 or 45. The other features is the business of the machine vendor or the manufacturer. The tip of the I&A handpiece has two ports, one for irrigation and the other one for aspiration. And as you can see here, it comes with different angulation, straight one or curved with 45-degree or 90-degree according to your preference. Some surgeons using bimanual I&A handpieces. The bimanual means the irrigation in one handpiece and the aspiration the other handpiece. All the handpieces should be covered with sleeves. Sleeves made by silicone material. The function of the sleeve to protect the cornea and internal structures from transmitted heats. And the other function of sleeve is distribution of irrigation, in which that 80% of irrigation emerges through the side opening and 20% emerging from the front port, front opening. Just to ensure the good flowability inside the AC. That's why we keep the side opening perpendicular, 90-degree perpendicular to the Phaco bevel. The body of the Phaco probe containing the piezoelectrical crystals, which is the generator of Phaco oscillation or movement. These crystals generate the movement or oscillation after converting electrical power to mechanical energy. Actually, the frequencies of the tip movement are fixed in each machine, ranging from 30 kilohertz to 60 kilohertz, and you cannot change it. It is fixed by the machine manufacturer. The current Phaco probes containing 4 crystals. The newer generations, they have 6 crystals. The more crystal you have, the more power generation you can get. The last part of any handpiece is the connection or tubing system. We have 2 types of tube system, one for irrigation and the other one for aspiration. These 2 circles representing the cross-section of the tubes. The one on the left side representing the aspiration tube system, and it has to be smaller in diameter and thicker in the wall and lower in compliance, so it will be rigid. In contrast to the tube of irrigation, it has to be larger in diameter, thinner in the wall, and higher compliance than the other tube. So it will be a soft. This difference making the tubing system is ideal for proper balanced fluidics. Foot pedal, which is the second cornerstone in Phaco machines, is the most important aspect and most difficult in controlling in Phaco machines. For every Phaco machine, there is a different foot pedal design or style, but it has to be the same principle again. Foot pedal has mainly 2 parts of functions or positions. The central part for central pressing positions and the side kick part of function. Starting with the central part of Phaco pedal, we have states of positions or indentation. Position 0, which is the state of rest. Once there is no press, once you start to press or indent with your foot, you will get the first position, which is irrigation, and the second indent, you will get the second position, which is the irrigation, as well as the aspiration flow rate, and the third indent, you will get the third position, which is the power beside the irrigation and aspiration. Between the positions, you will not feel any resistance, but you have to depend on your hearing feedback from the control panel, and you will get the changes in audible clicks or audible sounds, and there might be a fine tactile movement of your foot pedal controlling. Once you press down, it is the start of position 1. So the pinch of the infusion will open, allowing irrigation function. Here there is no linear control. That means the irrigation either on or off. The only way to control the irrigation and pressure inside the AC is the bottle height. And please make sure that the inflow is greater than the outflow to keep stable AC. In general, there is two ways for outflow or wasting of outflow, leaking or higher aspiration. And you can take the advantage of continuous irrigation mode. So you can set the continuous irrigation mode in the control panel, or you can preset in your foot pedal. If you are not comfortable with controlling by foot pedal. Last point in irrigation is the active fluidics, which is a new tool in newer Phaco machines, which depend on pressurized fluid, not the bottle height. When you reach the second indent, which is the position 2, the aspiration flow rate starting and the vacuum start to build up. In this position, you have linear control of outflow. Linear control means that the top of foot pedal in position 2 provide less outflow and vacuum than the bottom range of foot in position 2, as you can see here in this picture. The outflow and vacuum is working and generated by presence of pump inside the machine. Here you have ultrasound power activation after the third indentation. You can control the power by foot pedal, either linear or panel, according to your setting. Panel means you can reach the preset value open pressing. And if you are in position 3, already you are activating the irrigation aspiration. So you will not reach the third position unless you almost engaging the previous functions, which is irrigation and aspiration. Just to remind you with the central part functions of the positions, we have position 0, the rest position or rest state. Position 1, we have irrigation only. Position 2, irrigation with aspiration or vacuum. Position 3, almost you reach the power or ultrasound movement. What about the sidekick function of the foot pedal? Again, it depends on the manufacturer and it's independent to the main central functions. But the most common or the commonest function and the most important function is the reflux. In case of an advertent aspiration from tissue like iris or posterior capsule, which is activated by sidekick to the right or to the left in order to expel the material that you sucked. It's considered as an emergency tool. In some foot pedal design, you can activate continuous irrigation mode without referring to the panel control. So we have done almost with the hardware of the Phaco machine. Let us talk about the Phacodynamics principles or term and specifically. We have fluidics and power. These two parts of Phacodynamics ensuring, and if you know it very well and you can control it very well, it ensures that the more efficient procedure during Phaco surgery. Regarding the fluidics, it is the balance between infusion and aspiration outflow in order to maintain the AC. And again, to ensure that balance, we have to make sure that the inflow is greater than the outflow in order to have this good stability. As we have mentioned that the irrigation is controlled by bottle height. So it is called passive fluidics or passive infusion. And the bottle height above the patient eye creates the pressure gradient, and approximately or around 11 millimeter of mercury pressure is produced inside the eye for every 15 centimeter bottle height above the patient eye. So if you want 55 pressure inside the eye, you need to set the bottle height around 75 centimeter above the patient eye. Also, too much fluid is undesirable and can lead to fluctuation of the lens iris diaphragm. and iris prolapse. So making the balance is the mainstay of the fluidics. What about the active fluidics or active infusion? And the newer feature, which is a newer feature in newer machines, which you can control the irrigation with pressurized bottle inside the machine, either pressurized with gas pump or the paddles, controlling paddles. So no more gravity controlling. So they call it active fluidics. The other part of fluidics is the outflow, which is representing the fluid flowing through the aspiration tube, which is known as the aspiration flow rate, or AFR. It's measured by cubic centimeter per minute. And here we came up with another term, which is the flowability, which is representing the tendency of structures moving inward or outward the phaco tip. So the balance between the inflow and outflow, ensuring good flowability inside the AC. The optimum aspiration flow rate is 20 to 30 to 35 cubic centimeter per minute, but it can be adjusted according to your flowability inside the AC or the status of AC stability. There are two functions for aspiration system. First one is the aspiration flow rate, which means how fast the things is coming to the phaco tip, known as also the attractability. And the other term or other function is the vacuum, which is the negative pressure created inside the tube after occlusion happened. And we call it also holdability. So if you want to increase your attractability, you have to increase the AFR level. And for the holdability, you have to increase the vacuum level. Attractability is the rate at which the fluid and emulsified nuclear particles are removed from the eye when the phaco tip is not occluded. So we can adjust it with aspiration flow rate level. Whereas the holdability is the negative pressure that created when the tip is occluded and can be adjusted by increasing or decreasing the vacuum level. They are separate components, but working hand by hand during the outflow. How does the aspiration system generate it? As we mentioned before, the outflow system is generated by presence of pump inside the machine, which is mainly moves fluid through the aspiration tube. In general, we have two types, mainly two types, either the vacuum-based pump or flow-based pump. First type of pumps is the flow-based system or peristaltic pump, which is the most commonly used pump inside in phaco machines. As you can see here in this picture, the rollers moving and pinching the aspiration tube, which will create flow current inside the tubing system. And the rate of the flow or aspiration flow is controlled by speed of this roller or this pump. In this type of pumps, the vacuum level started in state of occlusion only. Once the occlusion happens, the vacuum is starting to build up and the rollers starting to be slowed down and the flow rate decreasing, approaching the zero level until you reach the presetted vacuum level. The other type of pumps systems is the venturi pumps, in which the aspiration function is generated inside the rigid cassette by presence of or by the currents of the gas inside the pipe, which makes and creates the vacuum pressure approaching negative level. So it creates the vacuum inside this rigid cassette and transmitted through the tube system, and the aspirating the fluid from inside the AC. The main advantage here in of this type of pump, the ability to create the preset vacuum level without occlusion of the Phaco tip needle. And as the surgeon, the preset vacuum is immediately created, so it's called a vacuum-based pump. In this case, in this type of pump, no need for occlusion. لأن الفاكيوم أو الفاكيوم already present in the rigid cassettes, creating the vacuum. ما يحتاج الاكلوجن to create the vacuum function. It will be clear in next slides. This type of pumps, only the vacuum can be controlled. The aspiration flow rate is fixed, and it is a function of the vacuum. And the vacuum is directly transmitted from the closed chamber to the tip of the phaco. يعني الاسبيريشن flow rate أو aspiration level is fixed with the vacuum. You cannot control the aspiration. You will control the vacuum only in this type of pump. In conclusion, the peristaltic pump, you have to have full occlusion to create maximum presetted vacuum. And inventory pump, you need only to press your foot pedal to have presetted level of vacuum. What is the rise time? It is the time required to reach the presetted vacuum level. So you will have rapid rise time inventory pump and slower one in peristaltic pump. And you can control it by increasing the aspiration flow rate level in case of the peristaltic one. Table to summarize the difference between these two pumps. In peristaltic pump, we have flow-based system. In venturi, we have vacuum-based system. Vacuum created only with occlusion in peristaltic pump. So you can reach the presetted vacuum level directly with pressing of your foot pedal. In case of venturi pump, flow rate is constant until the occlusion. Flow rate varies according to the vacuum level in the venturi pump. Drains in soft bags, so you can use soft bags in peristaltic. Only you can drain in rigid cassettes in venturi pump. It has larger safety margin if you using the peristaltic pump type, and less margin of safety in venturi pump. Longer procedure relatively in comparing the peristaltic to the venturi. Slower rise time here, so it is very safe pump to be used. Most of the widely used machines that you know it is a peristaltic pump related. Only some newer Phaco machines, they adding venturi pump as alternative or as alternating during the surgery, so you can swap between peristaltic and the venturi system. When we're talking about the vacuum, we have to mention this phenomenon, which is the surge, which is sudden withdrawal of fluid from AC after occlusion breaks. How does it happen? After occlusion, the negative pressure inside the tubing system is created and the tube starts to collapse. After breaks, the negative pressure become off and sudden gush of fluid inside the tube and shallowness of AC happen. Like this picture, the Phaco needle is occluded with piece of cataract. So the vacuum is starting to be built up, negative pressure reaching the maximum negativity here, and tubing system is collapsing because the negative pressure. Once this particles of cataract is emulsified and breaks, the negative pressure or collapsed tube will expand suddenly, leading to gush of fluid from AC inside the tubing system and leading to shallowness of AC, and this is very dangerous phenomena. You have to take care. In this video, it is showing representing the surge, which happens multiple times during the phacoemulsification. As you can see here, after breaks of occlusion, the AC is collapsing and everything is coming toward the phaco tip. I don't know, is it clear for you or not? But anyway, it is available on the YouTube. Just you can write surge during phaco. The manufacturer working on that phenomenon to overcome this problem by modulating and inventing newer technologies. So they reduce the compliance of the tubing system and make it more stiffer. They're using rigid cassettes instead of soft bags and making smaller tubing system diameter instead of larger one, and making a new differentiating in the setting of aspiration flow rate and vacuum pre and post occlusion. So you can adjust your parameter accordingly in order to prevent this gush of fluid. Other technology like venting or ventilation system, which is a sensor that detects occlusion breaks and release fluid and air into the system and filling the tube system. So eventually it will prevent sudden gush of fluid out of the AC. The other system is the ABS, which is aspiration bypass system, which is a small hole in the metal part of the handpiece. So even with occlusion, some fluid will pass by and passing through that small opening, and this small opening will open when there is occlusion, and as well it has the cooling effect of Phaco tip. Inside the machine solutions, the surgeon can adjust their parameters in order to overcome this problem by decrease the flow rate, increase the infusion bottle height, or increasing the IOP if it is active fluidics, decrease the vacuum level, but it might affect your holdability. With the expert surgeon, they can control their foot pedal pressing, so they can anticipate the surge, so they will control it more easily. That's about the surge. Okay, we have done with the fluidics, and the other part of the Phacodynamics is the power. Power means the frequency multiplier times stroke length. So power equal the frequency times stroke length. As we know that the frequency is fixed in Phaco machines, and it depends on manufacturer companies, and it varies around 30 to 60 kilohertz. So you cannot change the frequency. Frequency is fixed. Even if you changed your power, so the power is 80 or the power is 20, almost the frequency almost the same. You will not change it. So the only variable, the only variable that can change the power is the stroke length. Stroke length is the length of movement of the probe back and forth, and the Phaco power indicated by percentage of stroke length. يعني power of 20 means the stroke length is 20% of the Phaco needle length. 50% power means 50% or 50% of the stroke. The stroke length is 50% of the tip of the length of the tip of the Phaco. 80% almost you reach the maximum or below the maximum of your Phaco needle length. يعني الباور اللي يتحكم فيه stroke length بس. If we mean 20, that means your stroke length is 20. If we say 50% power, that means 50% stroke length. 80% power means 80% stroke length. But how does it emulsify the cataract? When we talk about the straight phaco tip, the main action here is jackhammering effect, which is direct impaction of the lens material and emulsification. And the second effect is the cavitation phenomenon, which is happen with when the tip is retracted very quickly. So I mean, the retraction of the phaco tip is سريع جدا لدرجة أن الفلويد cannot follow that tip. So produce tiny bubbles. These bubbles implode amongst themselves, creating shock waves. مع رجوع هذا الفيكو تب with jackhammering مع رجوع الفيكو تب backward, the fluid cannot fill this cavity, so it will create small tiny bubbles. These bubbles تنفجر أو implodes, causing shock waves that emulsify the materials of the cataract. But the problem with these shock waves or acoustic waves, it's causing shattering effect, which is repelling of the material from the tip of the Phaco Probe. So it might يعني إذا كان الباور عالي ممكن الشاترينج هذا يضيع عليك ال holdability of the Phaco Probe. So while you are holding the piece, and shattering is repelling the piece away from the Phaco Probe. So it might affect the time of power. To overcome this problem, a newer modification has been done by manufacturer, especially with the curved tip, which is the Kelman tip, like torsional ultrasound technology, elliptical or ellipsoid technology. Power delivery can be controlled by foot pedal, either with linear or panel modes. With the linear mode, you can control the power gradually to presetted level of power, and with panel you will reach the presetted maximum level of power once you indent the position 3 in foot pedal. يعني عندك we have two way of controlling. We have linear way and we have panel way. The linear way, once you start the position 3 and the foot pedal, you will start with 0 level of power until with pressing. إذا وصلت آخر حد في الدعسة حقت الفوت بدل, you will reach the presetted value of your power. يعني إذا if we choose 40 as a power in the control panel, you will reach it at the maximum pressing with a linear mode. But when you choose panel mode, you will reach 40 since beginning. So no matter what you are pressing. So you reach 40 once you press the position 3, or once you reach the position 3. Previous slides talking about the controlling of this power. Regarding the picture of energy delivered to emulsify the cataract, it has three pictures or 3 modes: continuous mode, pulsed mode, or burst. Continuous mode means the Phaco power is working all the time, but this mode has big disadvantage, which is the high volume of energy, almost all the second fractions full of power, which is harmful for the endothelium. This mode is suggested in sculpting of hard nucleus. We have also here in the continuous mode, you have linear controlling or panel controlling. بمعنى continuous mode كل أجزاء الثانية full of energy or full of power, but we have linear or panel according to your setting. Whereas the pulsed mode, you will have on and off periods almost equal in duration. So 50% of time there is power, and 50% of time there is no power or off period. The idea of pulse mode to improve the holdability and attractability in off period and decrease the heat production. Difference between the pulse and hyperpulse that in older machine system, you cannot exceed 20 pulse. But in newer machines, it reaches hundreds of pulse per second. الفرق بين البulse والcontinuous. Continuous, as we mentioned, that all the time is filled with power. But in pulsed mode, 50% there is off periods. So there will be less heat production. What about burst? Burst mode, there is no linear here, only panel controlling. Only so the maximum presetted power is delivered upon pressing the foot pedal. With pressing more with the foot pedal, only you are controlling the burst intervals. So starting with variable burst till you have continuous mode at the end of pressing. This mode is beneficial when you have different nucleus intensity. بمعنى once you start the position 3, you will have larger intervals of off period. مو زي البulse you have 50% of off period. Here you will start with larger time of off period. Then this off period is minimizing till you reach almost continuous. يعني على آخر الدعسة of the foot pedal you will reach continuous mode. هذا burst mode. With the newer technology and they adjust the pulse rate and the duty cycle. The duty cycle زي ما قلنا هنا pulse we have 50% of time this is the duty cycle. So the duty cycle means the Phaco on time over Phaco on time plus Phaco off time. In these two examples, we have the same power, okay? And we have the same pulse. We have 3 pulse here and 3 pulse here. But the difference in the delivery of this energy, that the first example, we have 20% only of time that is on. And in the second example, 50% of time that is on Phaco power. So the duty cycle here in the first example is 20%, and duty cycle in the second example is 50%. Lower duty cycle is better to increase the efficiency and decrease the energy and heat production. So they name it as a cold Phaco technology. During sculpting, you can use a higher duty cycle. When you are doing quadrant removal, you can use lower duty cycles. At the end, تقريبا هذه النهاية. These are 4 variables that you need to adjust it during Phaco procedure. يعني هذه الأشياء اللي ممكن تعدلها وقت الفيكو. Bottle height to adjust the irrigation gradient and the power with percentile, and vacuum with millimercury of pressure, and the aspiration flow rate with cubic centimeter per minute. These only the 4 parameters or 4 variables that you need to change it. Besides the angle of the Phaco tip, so you have to choose. They will the nurses will ask you about these things. They will ask you which angle you will use or which tip you will use. You will choose 30 for softer cataract or 45 for harder cataract. And they will ask you what kind of setting you will use during quadrant, during sculpting, during cortical removal. So you have to adjust these things. And that's it. Conclusion: increase flow rate to increase your attractability, increase the vacuum to increase the holdability, and balance the fluidics for better flowability, good flowability ensuring the stable AC. طبعا Phacodynamics is complicated and a huge subject. I try to minimize the terms. يعني على الأقل تعرفون بعض التيرمز like الشاترينج، الباور، البانل، البيرست، المولز هذه الموجودة. Tomorrow there will be a clinical part of Phacodynamics by Dr.Turki Bin Dakhil. I encourage you to attend. Very nice lecture إن شاء الله بتشوفها. الله يسر امورنا منكم. جاهز الاسئله اذا احد عنده اسئله. بسم الله. What a venturi system offers over the peristaltic for the surgeon. Okay, as we mentioned, غالبا the venturi system is present in vitrectomy machines. يعني تحصلونها عند retina surgeon. You will find the vitrectomy machines. In some phaco machines, they have venturi pump for the more expert surgeon, and they are aware about the search لأن بيكون معها يعني الموست اللي هو the collapsing of AC and everything is coming to your side very quickly. بتخلي شوي السيرجري more faster. هذه ممكن الادفانتج حقت الفنتوري، لكن it is very risky pump. Okay, please repeat duty cycle. Okay. Okay, duty cycle. أساس نفهم duty cycle we have to repeat the pulse mode. طبعا الباور هو شوي complicated. الباور عندنا الكنترول، كيف تتحكم في الباور وكيف أشكال الباور. كيف نتحكم في الباور اللي هو الفوت بدل، دعسة الفوت بدل. عندك linear or panel، سواء يعني الكونتينيوس عندك linear or panel، والبلس عندك linear or panel. خلي البيرست على جنب شوي. طيب المود of energy delivery اللي هو الكونتينيوس، يعني كل الأجزاء الثانية كلها فيها باور. اوكي، هذا في الكونتينيوس. طيب either linear ولا panel، كل الأجزاء الثانية مليانة باور. اوكي، البلس حط فيه off period او 50% of time is off. يعني مثلا لو شفنا الأجزاء الثانية فيها 1000 جزء، 500 جزء من الثانية off، 500 جزء من الثانية on بشكل alternating، بحيث أن تخفف الهيت برودكشن. طيب وتزود الهولدابيلتي. طبعا الفكرة هذه طلعوا منها اللي هو الديوتي سايكل. 50% of time that there is on power they develop the duty cycle. فالبالس مود معناها الديوتي سايكل is 50%. المودرن تقدر تتحكم في الديوتي. اول كان البالس كانت كنترول الديوتي سايكل. Now في المودرن فيكو technologies you can adjust your duty cycle. So you can adjust it according to your step. يعني مثلا إذا أنت في السكالبتنج تخلي الديوتي سايكل very high، يعني تخليها من 50% of time is on. في الكورتيك في الابينيكلس ولا الكوادرنت ريموفال تخليها very low، تخلي مثلا 20% of time is on. هذا الديوتي سايكل، يعني الوقت اللي شغال فيه الفيكو من الأجزاء الثانية. الأجزاء الباقية من الثانية تعتبر اوف بيريد. الجزء اللي فيها باور تسمى الديوتي سايكل أو تسمى الفيكو باور اون تايم. Okay, what is the difference between the burst and continuous linear mode? It looks somehow similar. Okay, there is difference in linear. طبعا البيرست there is no linear mode, but let us return back to the linear mode في continuous. مثلا فرضا لو if we choose 50 of power، يعني حطينا في الكنترول بانل 50 power. okay, if you choose linear control، أول ما توصل البوزيشن 3 باليور فوت بدل you will approach zero power. مع الدعسة الزيادة it will increase, the power will increase, but almost there is on time. يعني كل الأجزاء الثانية شغالة فيها باور. صح إن هنا الباور 10، هنا الباور 20، هنا الباور 30، هنا الباور 40، هنا الباور 50، بس كل الأجزاء الثانية فيها باور. عكس البيرست في البداية، طبعا البيرست ما فيه لينير، فيه بس الدعسة حقتك تخفف الأوف بيريد. البيرست بيكون فيه باور في البداية، بعدين الأوف بيريد حقتها بعيد طويلة شوية. طبعا هذه كلها بأجزاء من الثانية، لكن أساس التبسيط. بعدين بيكون عندك باور تاني، باور I mean ultrasound movement. Then the off period becoming less than the previous off period. طيب بعدين تخف الاوف بيريد عندك لين توصل في النهايه كانها كونتينيوس، مو كونتينيوس بس كانها كونتينيوس مود. اوكي، لكن عكس اللي هو الكونتينيوس كل الاجزاء الثانيه فيها باور. هنا البلس فيها اجزاء من الثانيه ما فيها باور، برضه البيرست فيها اجزاء من الثانيه ما فيها باور. اتمنى انها يعني وضحت، معليش يعني، بس لكن هو الفيكو داينامكس بشكل عام مزعج، لكن اتمنى تكون ان شاء الله بسيطه. اوكي، ثانك يو، يعطيكم العافيه جميعا. ثانك يو. So the inventory system, the vacuum can build even in air without the be included by lens piece, and that's why make it risky. صحيح، في الفنتوري هو زي معليش يعني زي المكنسة حقت البيت، المكنسة الكهربائية فيها داخلها فنتوري، فبيشتغل عندها نيجاتيف بريشر في أي مكان عندها قابلية للسحب. النيجاتيفيتي اوف بريشر انسايد الفنتوري تنتقل لداخل الاي سي، في الفلويد اللي داخل الاي سي يعني في النهايه ينتقل داخل التيوب ويتجه للمشين، يعني على اساس النيجاتيفيتي كرييتد انسايد التيوب. هذا اللي يخليه ريسكي. نعم صحيح. طبعا الفيكو داينامكس في البدايه اول ما تسمع المصطلحات هذه بتكون صعبه وتحس انها كثيره، تحس انها تلخبطك وقت الفيكو بروسيجر، لكن مجازا you can do your first phaco procedure without knowing these kind of terms. يعني تقدر تسوي أول حالة لك كاتاراكت فيكو بدون ما تعرف الكلام هذا كله، لأنها فعليا الفيكو machines is by practice and by experience. But once you have done the first and your first cases, you have to refer and refine your skills with the Phacodynamics. يعني لازم تكون عندك خلفية شوي في Phacodynamics، تعرف how to adjust your parameters. طبعا البارامترز اللي بتغيرها اللي زي ما قلنا الأخيرة هذه اللي تحتاج تغيرها في فيكو. الباور طبعا يطلع لك في الشاشة الباور 70، ما راح يطلع لك لينير بانل بيرست، هذه كلها تدخل داخل باور. هو غالبا الفندر يكون معك ويصلح اللي تبغى، لكن إذا تبغى تصلح your setting you have to click into power and changing your parameter accordingly. طبعا البارامترز تتغير من sculpting، الكوادرنت، الابينيكولس and cortex removal. البارامترز هذه ما راح تكون ثابتة، راح تكون متغيرة. إذا ما في أسئلة طبعا we have to conclude. طيب يعطيكم العافية جميعا. طبعا بكرة محاضرة الدكتور تركي، ضروري جدا تسمعونها. It's very important. بتلخص لكم كل اللي صار، وفيها clinical aspect كثير، وفيها diagramming زي العادة. الدكتور تركي متميز بالlectures، فضروري جدا تحضروها. بالتوفيق والجميع.